This video is to work through the problems on quiz 2.4 to 2.5, quiz A. So let's start with number 1. Number 1, we're dividing two numbers with the same base with different exponents. So we can use our exponent rule of subtraction. So this is going to equal 3, so the base doesn't change. And you subtract your exponent, so 5 minus a negative 3. And we don't like double negatives, so when we have a double negative, that means both become a positive. So this is actually 5 plus 3, so the answer is 3 to the 8th power. Okay, so for number 2, we have a power raised to a power. So when we have a power raised to a power, we multiply our exponents. So we have 4 to the 3 times 5 power, and that's going to equal 4 to the x. So we're just trying to solve for what that exponent is. So 3 times 5 equals 15. So our x equals 15. Okay. If we look at number 3, we're dividing a monomial divided by a monomial. So we want to break it into our different terms and divide each of them separately. So first, if we divide 9 divided by 3 squared is actually 9, so 3 times 3. So that's going to be 9 divided by 9, which actually just turns into 1, so they cancel out. Then we have a to the third divided by a to the negative third. So when we divide with like bases, we subtract the exponents. So that's going to become a to the 3 minus negative 3, double negative, so it becomes a plus plus. So we end up with a to the 6th power. Okay, and then if we look at our b's, we have b to the 4th divided by b to the 0. And then when we divide again, we subtract the exponents. So we have b to the 4 minus 0 power, which just equals b to the 4th. And really you don't need this 1 in front of here, so you could simplify this to a to the 6th, b to the 4th as your final answer. Okay, so now if we move on to number 4, this has several things going on. We're multiplying two monomials, but before that, we're raising a power to a power. And if you follow PIMDAS, we need to take care of this parentheses and exponent before we can multiply. So power to a power rule means that we multiply exponents. And be really careful here, because your exponent on your 2 is 1. We're not going to multiply 2 times 3. We're going to multiply 1 times 3. So we're going to distribute this to both of the powers, and we end up with 2 to the 3rd x to the 2 times 3, which is 6, and then we just keep that y. We bring everything else down, and now we are just multiplying two monomials. So we can multiply by like terms. So first we can multiply the numbers, and looking at 2 to the 3rd, that's really the same thing as 2 times 2 times 2, which is 8. So we're going to get, let's see, 2 to the 3rd equals 2 times 2 times 2, which equals 8. So we have 8 times 4, which equals 32. Then if we look at our x's, we have x to the 6th times x to the 4th, when we multiply, we add exponents. So x to the 6 plus 4, which is going to give us x to the 10th. And then we look at our y's. Be careful, because when there's not an exponent listed, it really is 1. So we have y to the 1 plus a negative 5. So we end up with y to the negative 4th. Okay, and remember, we don't like negative exponents, so we use our flip rule, where everything that has a positive exponent stays where it is. So 32x to the 10th stays in the numerator, but to get rid of that negative exponent, we flip it to the other side of the fraction, and we change the sign. So our final answer is 32x to the 10th, y to the 4th. Whoops. So I didn't move my paper up. I'll make sure to be watching that in the future, guys. Sorry about that. Okay, so just to repeat, since the paper wasn't showing, we had to distribute this 3 to both of our exponents and use the power to the power rule to get 2 to the 3rd, x to the 6th, y to the 1st. Then we just carried down the rest of the problem. Then we multiplied these two monomials. When you multiply, you add the exponents. So that's what we did. We took 2 to the 3rd, which equals 8, times 4 to get 32. X to the 6th times x to the 4th. We added the exponents. 6 plus 4 equals 10. And then y to the 1st times y to the negative 5th. 1 plus negative 5 equals negative 4. And then again, we don't like negative exponents, so we flipped it to the denominator and we changed the sign. Okay. So let's look at number 5 now. Okay, so we are dividing two monomials, but we also have a power to the power rule. So we first need to take care of the parentheses and the exponent because of PIMDAS. So again, power to the power rule means we multiply the exponents. So we have to make sure we know what our exponents are for all of these. So the exponent on 3 is 1. So let's go ahead and distribute 4 to each of these. So we have negative 3 to the 1 times 4 is 4. 2 times 4 is x to the 8th. And then 3 times 4 is y to the 12th power. And then we just keep our denominator. And now we are just dividing. And we can make sure to divide our common terms. There's no x value, so okay, so first we have to evaluate negative 3 to the 4th power. Okay, so that's the same thing as saying 3 times 3 times 3 times 3, right? So if we put that in our calculators, we get 81. And remember, because this is not in parentheses, the negative is not in parentheses, we're only taking 3 to the 4th power, and then the answer stays negative. Okay, so we have negative 81 is what that equals. So we end up with negative 81 over 9, which if you divide negative 81 divided by 9, you get negative 9. Then our x value stays the same because there's no x to simplify the x to the 8th with. Okay. And then we have y to the 12th. So x to the 8th. Y to the 12th divided by y to the negative 3rd. When we divide, we subtract. So that ends up being I'm just going to write it over here. So we have y to the 12th minus a negative 3 plus a positive, so that we end up getting y to the 15th. Okay, and actually, I didn't read the problem all the way. I did some extra work. Number 5 only asked for the coefficient. So what we could have actually done was stop right here, because coefficient means the number in front, not the variables. Okay, so it's okay if we do some extra work. You guys may have done this too, but when you read the question again, it says coefficient only. So we're only going to answer -9 because that's the coefficient. Okay, so we're going to move on to number 6. Number 6, we are again dividing. Okay, so we want to separate our terms. Okay, and we're going to first start with dividing 24 divided by 4, which that equals 6. And then we're going to divide a to the 6 divided by a to the 3rd. When we divide like bases, we subtract the exponents. So we have a to the 6 minus 3, which that equals a to the 3rd. So I can bring the rest of this down. So this is our answer so far, 6a to the 3rd. And then we look at our last term, b to the -7th divided by b. And technically, right, there's a 1 there for your exponent. So again, when you divide, you subtract your exponents. So it's going to be b to the -7 minus 1, or plus a negative. So we end up with b to the -8th power. And again, we don't like those negative exponents in our final answer, so we're going to keep everything with a positive exponent, and then we flip the variable with the negative exponent across the fraction line and change the sign of your exponent. Okay, so our final answer is going to be 6a to the 3rd divided by b to the 8th. Okay. So if we move on to number 7, we have another division problem where we're dividing a monomial by a monomial. So we separate our terms. So we take 5 divided by 30. And what we end up doing is we look at what number can we take out of both of these. Both of them can be divided by 5. So 5 divided by 5 is 1. 30 divided by 5 is 6. Okay, so then we have x to the 4th divided by x to the 9th. When we divide, we subtract our exponents, so we end up with x to the 4 minus 9, which that will be, so plus a negative, so we end up with x to the -5th. So far we have 1/6 x to the -5th. And then we look at our y's. We have y to the 11th divided by y to the 5th. So that means we subtract our exponents, 11 minus 5, and we get y to the 6th power. Okay, so if we put everything together, we have in the numerator x to the -5th, y to the 6th, divided by 6. And then we don't like those negatives in the exponent, so everything that's positive stays where it is. And we flip this x to the denominator, and the exponent becomes positive. Okay, so that's our final answer. If we move on to number 8, so we have a monomial divided by a monomial, and we're raising that all to the 4th power. So because the parentheses is around the whole fraction, I would suggest that you first simplify inside the fraction and then raise the power. Okay, so we're going to take 14 divided by 7, and we get 2. Then m to the third divided by m to the third. Anything divided by itself is just 1. We could also use our exponent rules though. So we have m to the 3 minus 3, because when we divide we subtract exponents, and that equals m to the 0 power. Anything to the 0 power equals 1. So no matter which way you do it, whether you just cancel out the numbers or variables that are the same, or you use your exponent rule, you still get the same thing, which is 2 times 1. So the m cancels out. Okay, so we end up with 2 so far. Now we move on to n to the 8th divided by n to the 11th. And when we divide, we subtract our exponents. So n to the 8 minus 11, which equals n to the negative 3. Okay, so we have 2n to the negative 3. And we can go ahead and flip that already, right? So we have 2 to the n to the third, and we can't forget about raising that all to the 4th power. Okay, so now power to the power rule means that we multiply our exponents. I'm going to write my exponent in here so I don't accidentally multiply 2 times 4. So I end up with 2 to the 4th power divided by n to the 12th power. So then we have to evaluate 2 to the 4th power. So it's 2 times 2 times 2 times 2, which equals 16. So our final answer is going to be 16 divided by n to the 12th power. Okay, so now we're moving on. We're adding some geometry in. So determine an expression for volume of the cube below if the side length measures 5x to the 5th. So volume equals length times width times height. A special characteristic of a cube is all of these 3 things are the same. So we really could say volume equals length times length times length. You can simplify that using our exponent rules and say volume is L to the 3rd power. We know our length, so we can just go ahead and plug that in. So volume is going to equal 5x to the 5th raised to the 3rd power. So now we have a power to the power rule. Remember to write in your exponent if that helps you. So we're going to have 5 to the 1 times 3, which is 3rd power, and x to the 5 times 3, which is 15 power. So 5 to the 3rd is the same thing as saying 5 times 5 times 5, which equals 125. So our final answer is 125 x to the 15th. Okay. Then number 10 says determine the volume of the cube with the same length measurement, but now you know what your x value is. So what we can do is just plug in 2 for x. So we already calculated our volume, which is 125x to the 15th, and we just plug in 2 for x. So 125 2 raised to the 15th power. And if we put that in our calculator exactly as you see it, you end up getting, give me a second to get my calculator. (125) times 2 raised to the 15th. We end up getting 4,096,000 cubic feet. Okay, and if you look at your answers, none of them match. because you have two options in scientific notation. So we can go ahead and change this to scientific notation. Our decimal starts over here, so we have to move it over so that there's just one digit in front of the decimal. So we move it over 1, 2, 3, 4, 5, 6. Okay? And remember, scientific notation, you only have two places after the decimal. Okay? So we need to round at this point. So, because 6 is greater than 5, that's going to cause us to round up. And because we have a 9, we have to round up again. So we end up with 4.1 times 10 to the, it was 1, 2, 3, 4, 5, to the 6th power as your final answer. Okay? So we're going to move on to number 11. Okay, so it says the length of a rectangle must be what inches, how many inches, if you are told the area of a square is 24x inches and the width is 6. So you know that area equals length times width. If we're solving for length, we can divide by w, divide by w, cancel this out. Now we have an equation where length equals area divided by width. And we can go ahead and plug in our numbers. So area equals 24x, width equals 6. So we're dividing a monomial divided by a monomial. Separate our terms. 24 divided by 6 is 4. There's nothing to divide this x with, so x just stays. So your final answer is 4x. Okay. So for number 12, the side length of a square must be how long? If you're told that the area is 100x squared. So a square is special because all the sides are the same, right? So we need to find one side times another side that equals 100x squared. Well, what number times itself equals 100? So you can do this in two ways. You can do guess and check, and you can try different numbers, or you know that any number times itself, that's going to be a perfect square. So if you work backwards, you can find the square root to find your separate number. So you could take the square root of 100x squared. The square root of 100 is 10, and the square root of x squared is x. And then we can check and make sure. Does 10x times 10x equal 100x squared? Well, 10 times 10 equals 100. X times x, when we multiply, we add our exponents. So 1 plus 1 equals 2. So yes, the answer is going to be 10x. Okay. So now we have a polynomial, and we need to write this in standard form. Standard form means you write it in order from an exponent with the highest degree to lowest degree, and then you write the constant number. Okay, so the term with the highest degree is 5x to the 7th. The next term is negative 12x to the 5th. Then we have 4x technically to the 1st. Okay, and then we have our constant, negative 9. Okay, and I'm going to have to stop here because I have some office hours people coming in, so I'll finish the rest later.